Good morning. We're going to go ahead and look today at a slope-intercept form of a line. So first of all, we're going to write an equation. Okay? So the slope-intercept form is always in the form of y equals mx plus b. M is your slope, b is your intercept. So when we are given the slope of 3 and the intercept of -1, our line would be in the form of y equals 3 times x minus 1, because we're adding a -1. Coming down to the next one, okay, we've got a slope of 1/2 and a y-intercept of 0. Y is the dependent variable. It changes with our x, so we just leave our y in here. Then we have 1/2 x plus 0. I could write it, but it's redundant, so I would rather see this one in the form of y equals 1/2 x. I'll give you a moment to copy that down. Just pause the video if you need. Okay, so now we're going to look at finding a slope-intercept form of a graph of a line from a graph. So the first thing I'm going to do is I'm going to look at these perfect lattice points where it crosses exactly. And from there, I'm going to calculate my rise and my run. I could go from point to point, but here I've got an intermediate point. I'm going to go ahead and start here. I have a rise of 2. I have a run of 2. So that gives me an overall slope, m, equals 2 over 2. My intercept is where it crosses this axis, and it's crossing at a -2. So y equals the slope. Well, 2 over 2 reduces to 1 of 1x minus 2. It could also be written as x minus 2. And had I been particularly observant, I would have noticed that we had perfect lattice points all along here. Give you a minute to look at that. Coming over to our next example, I've got a point at 0, -1, so my intercept I already know is -1, and a second point down here, and I'm going to look, again, I've got a lattice point here, here, and here. I'm going to look here. It goes down 2 before it goes, it goes down 1. It goes down 1 before it moves over 3. So it has a slope, m, -1 over 3. So to write that equation, y equals -1/3 x minus 1 from this intercept here. And if you'll see, this line has got a negative slope. As x increases, y decreases, defines negative. It's a constant rate of change. Okay, looking down here, we are going to go from points. Got a point 0, -6, and a point 3,9. I know that slope equals the change in y, so it's y2 minus y1 divided by the change in x, so that would be x2 minus x1. I'm going to just define this one to be the first point and this one to be the second. So here's x1, x2, y1, y2. It's always a good idea to label these. So this would be 9 minus 0, minus -6, y2 minus y1 divided by x2 minus x1. Well, 9 minus a -6 is 15 over 3. So that's my slope. When x is 0, I have my y-intercept. My y-intercept is -1. So y equals 5x minus 6. The slope is 5, 15 over 3. The y values went from -6 to 9 and 0 to 3. Okay, so 15 over 3. And it crossed at -1. Give you a moment for that. And again, the slope is the change in y, so it is y2 minus y1 divided by x2 minus x1. So in this case, y2 is 2 minus negative 1, x is 0 minus 4. My slope would be 2 minus a negative 1 is 3, negative 3/4. My equation, okay, it's crossing at when x is 0, y equals 2. This is my intercept point. So y equals negative 3/4 x plus 2. I'll give you just a moment for that one. Now, if we look at this from a function, f of 0 is negative 4. Well, these are written of f of x equals, and f of x equals our y value. So when our x is 0, y is negative 4. We just got our intercept. When x is 3, y equals 8. And we're going to go back up and use our points from points. So I've got my two coordinate pairs, m equals y2 of 8 minus negative 4, this is y1. x2 is 3 minus 0, which is x1. 8 minus a negative 4 is 12, divided by 3, so my slope is 4. When x is 0, I've got my y value, my y-intercept, which is negative 4, so this is y equals 4x minus 4. In case you're a little confused as to why I'm saying this is my intercept, if I come up here, when my x value is 0, it's crossing my axis at negative 2. When my x value was 0, it crossed the y-axis, the y-intercept, at negative 1. I'll give you a moment if you've got to look at this bottom one. And we're going to do one last problem, and this is that real-life situation. In 2000, the average cost for college tuition in the United States was about $14,000. In 2010, the cost was $18,000, so I'm going to underline in 2000. And in 2010, they tell us it's linear with this expression right here. Write a linear model. They're looking for an equation. In the number of years since 2000, this is a second question. Use the model to represent 2020. So I'm going to look at my ordered pairs. So my x value controls, so it is an x value. I'm going to set this as year 2000. That's my 0 year, and the cost was $14,000. And 10 years later, my x value would be 10. My y value is now 18,000. So x1, y1, x2, y2. And it does not matter which one you designate as x and y. You will get exactly the same value each time. So this is going to be my intercept at 14,000. And my slope is going to be y2 minus y1 divided by x2 minus x1. So my y2 is 18,000 minus y1 of 14,000. x2 is 10 minus x1 of 0. So it is 4,000 over 10. So the meaning of this slope is that tuition was rising $400 each year. So the cost equals 400 times the number of years plus that base price, that initial starting value of $14,000. So say in 2001, it would have been $14,000 plus 400, which is over time, over 10 years, we're going to get to $18,000. Now the next question is in year 2020. So our x value is going to be 20, and I want to know what y equals. So y equals 400 times 20 plus 14,000. So this would be 4 times 2 is 8, 3 zeros, plus 14,000. So the cost of tuition that year would be $22,000, assuming 14 plus 8 equals 22, and I'm pretty certain it does. Okay, so in 2020, the cost of tuition will be $22,000. Thank you very much.